Hello and welcome to this lecture on Chapter 5. The topic is System Software. We'll be looking at system software, the operating system, and how it's different than application programs. We'll delve into the operating system and what it does. We'll look at operating systems for personal computers and laptops. We'll look at operating computers for mobile devices, smartphones and tablets. We'll talk about utility programs, and then we'll just give a hint about the future of operating systems. So let's get started here. System software is the topic of Chapter 5. Application software is the topic of Chapter 6. The difference between these two is that the system software is what operates the system. Now there's the operating system itself, and then there's utility programs that make the operating system even more effective, but their purpose, the operating system and utility programs together, is to operate the system. They don't do anything. You don't write research papers with the operating system. That's an application program. You don't surf the web with the operating system. That's an application program, a web browser like Internet Explorer or FileZilla or Chrome or your device. You don't edit a photo with the operating system. You use Photoshop or Paint or some program for that. So all the things that you actually do with the computer are application programs. The applications you install on your phone and on your tablet are applications. But the system software is important because the system software manages the system. It manages the hardware. It manages the interface between you and the system so that you know what it is, the computer knows what it is that you want to do. So we'll talk about the productivity application programs next chapter. This chapter, we want to just focus on the operating system itself and the utility programs that complement the operating system. Now, this text has a lot of text in this slide, but I thought it was useful to have on here. So let me just go ahead and read this. A computer's operating system is a collection of programs that manage and coordinate the activities taking place in the computer. The operating system operates the system. The operating system, it boots the computer when you turn it on. You have to have an operating system for the computer to boot up. It manages the hardware, the CPU, the memory, the storage, the printers, the network connections. It interfaces with the user. It gives you a way to talk to the computer and say, print this file, open this file, run this program, delete this program, right, whatever you want to do. And it launches and manages the applications. The word processor, the PowerPoint presentation, the Adobe Photoshop that you want to use, the Microsoft Money to manage your taxes, all of the application programs, Chapter 7, not this Chapter 6, Chapter 6, not this Chapter 5, all the application programs next chapter communicate with the operating system to get to the hardware. So for example, and this again, just read this blurb to you, when you issue a command to your computer to store a document on your hard drive, okay? You don't know how the hard drive works. You don't know how to spin the platters, and neither does Microsoft Word. Neither does PowerPoint or Excel or Adobe Photoshop, but the operating system does. So I give the command, print the file, or I use give the command to print the file or save the file from in Word or PowerPoint or Photoshop, but the command gets passed on to the operating system. The operating system executes the command because the operating system knows how to do that. It makes sure that the hard drive exists, makes sure that there's space on the hard drive. It updates the hard drive once the file's been saved and keeps up with the record of where the file's at and how big the file is. So it's really important, even though it's something that we kind of take for granted, that you can open a file and save a file and the computer knows how to do it. So the functions of the operating system, this chart on the right kind of shows the idea of a conductor making everything work together. That's an analogy of a computer, the operating system as a conductor. And it does all the things we talked about, booting the computer and providing an interface to the users. And by the way, the interfaces used to be on the old computers command line, and even the first personal computers used command line text-based commands. But with the Macintosh, which came out in 1984, and then Windows, which came out later than that, started using graphical user interfaces, and that's what we're commonly used to now. In the future, we might get voice-based rather than being physically touching with a mouse or touching the screen, the commands to double-click an icon to open it, to drag it, or to hit the delete key to delete it, and so on. Boots the computer, provides a user interface, configures all the hardware devices, making them all work together, managing the networks, monitoring the processes in the CPU, managing all the memory, and all the files on the hard drives, right? It does all those things for us. So a few of the things and a few terms that you want to know as part of reading this chapter and taking this away from you. There are four big terms on this page: multitasking and multi-threading and multiprocessing and parallel processing. Multitasking is the most common term of all of these. It's going to be used most often. If you did a Google search of these terms, you'll get more hits with multitasking than you will the others, probably. Multitasking means that I've got a single CPU, but I've got more than one process running on a CPU. Now, today's CPUs, because of Moore's Law, getting smaller, smaller, faster, faster, are multi-core. That is, that they basically have two or four or 8 processors on a single chip. 5 years ago, 10 years ago, that wasn't the case. You had one CPU chip in your computer. But you wanted to do more than one thing. You wanted to run the operating system. You wanted to run Microsoft Word. You wanted to run a media program that played music or video. And you didn't want to have a separate CPU for each of those. So multitasking is allowing you to have multiple tasks or programs that are taking time sharing the CPU as a resource. And even today, in multi-core processors or multiple processors on the board, we still multitask because a single program has multiple things going on. If you pull up your task manager, which you can do by right-clicking down on the taskbar across the very bottom and selecting Task Manager, you'll see that there are actually, on this machine that I'm looking at right now, I have 7 applications running. We'll talk about applications next chapter. I also have a number of background processes running, right, that I'm not actively running them myself, but they're all going on either by the operating system or by programs that are doing things that that I might use in the future. And then there's some things that are specific to the operating system and the services. So I've got 27 plus 37 plus 7, right? I've got 60, 70 some processes or tasks that are running in my task manager. Multitasking allows me to have all those things running at once on this machine, even though I only have 8 cores. It's 4 or 8 cores on this particular chip on this machine. I forget what I have. Now, so multitasking means multiple programs sharing the same CPU. They do a time sharing kind of a thing, and it's really cool. Multi-threading is a little more technical than what we want to talk about, but within a single program, like just within Microsoft Word, you want to have multiple threads going. So you've got a spell check going on with it, Microsoft Word, and you get the little tilde blue lines, the blue underscores as you have grammatical or spelling errors as you're using Microsoft Word, and Microsoft Word is doing your editing, your live editing, and responding to the menu clicks when you pull down menu choices, and when you print a file, that it's working with the operating system to take care of that print file while you're still editing your program. So the idea of multi-threading is just within a single task, there are multiple things going on, and it handles that as well. Now, what about multiprocessing and parallel processing? The idea here is that modern computers have multiple CPUs, and each CPU, of course, is multitasked. Each CPU is able to handle 4 or 5 or 10 or 20 different tasks and share that resource. But what happens when I have more than one CPU? Then I'm getting into this idea of multiprocessing and parallel processing. So this figure from our book shows, on the top figure, we see the sequential processing that is multitasking and multi-threading many threads within the same task. Here we have 2 CPUs, CPU 1 and CPU 2, for the bottom 2 figures. And in multiprocessing, I'm dividing up the blocks of work. Some goes to CPU 1 and some goes to CPU 2, right? So it's a little faster. I can get through more with 2 CPUs. Parallel processing is the idea that a single task is going to share 2 processors. And some things work well with parallel processing, and some things don't work well with parallel processing. The old analogy is it takes 9 months to have a baby, even if you have 2 or 3 women, working on the process at once. Some things can't be multi-processed, but some things can be multi-processed. If I'm rendering an image for a Pixar movie and I'm the company creating all those frames per image, I can have multiple CPUs working on rendering a single image, each individual frame of my 48 frames per second and 60 seconds per minute and 120-minute movie. Right? I can throw multiple processors at the same task. So some things can be broken up and some things can't be broken up. A long mathematical equation where you have to do A plus B first, and that result gets multiplied by C, and that result gets divided by D, and that result gets raised to the third power, and that result gets divided by something else. That can't be, you have to do that in sequence. Right? So that would be multi-processed, and this top CPU might handle all of those tasks to do that long calculation, but some things can be parallel processed. Okay, just some technical terms, but the most common of these is the multitasking, which is what we do on our basic. When you pull up the task manager, you've got more tasks running on your computer right now than you have CPUs to run those. That's multitasking. The operating system manages the CPU and CPUs. The operating system manages your RAM, your memory, probably your second most valuable resource. CPU, your most valuable resource. Memory, your second most valuable resource. And it does a lot with memory management that we're not even going to get into. For example, when I have 72 tasks running, they each have to have their own separate place of memory, and they can't copy over each other's memory. The operating system has to manage that. So that's an issue. The one thing I will say about memory management that's worth you knowing and probably seeing on the exam would be this idea of virtual memory, because it's kind of a neat idea. If I've got 72 tasks and each task requires a certain amount of memory, right, I've got to have a chunk of memory for all those tasks to have all the memory that they want. And even if I have a lot of memory, there's going to be times where I might not have enough memory. So the operating system handles that not by crashing, but by doing something very creative called virtual memory. The operating system takes part of the hard drive, which is slower than the RAM memory, but it takes part of the hard drive and says, we're going to treat this hard drive like memory. So if I've got some files, or I've got some data, or I've got some program, or I've got something that I want to work with, the operating system will use the hard drive as necessary to store some of memory. And what happens is when you actually need the data, usually it's in main memory on the RAM chip, but if you need the data and it's not there on main memory on the RAM chip, it'll go off to the hard drive, get the data you need, and bring it into memory, and then pass it on to the CPU. It slows things down when you have to go that extra step of going to the hard drive to get the information you need. But it allows the program to have access to its memory on the RAM chip, and to have access to its, quote, virtual memory that's actually just data stored on the hard drive. The operating system does all that for you. It does it all seamlessly. You don't even notice it. The operating system manages your storage, not just from a virtual memory pretending it's memory storage, but from the actual files that are actually stored in folders and subfolders. And the path name that's being used, and the file name, and the rules for file names that you're allowed to use, and the file extensions, the .pptx for a PowerPoint, and the .docx for Word documents, right? The operating system is using all that information. That's how the operating system graphically gives you the icon for a Word icon, like John, Mary, and Bill in English in this example, and a .pptx file extension is a PowerPoint, and you get the icon for PowerPoint on history. And when you double-click on the file to launch it, the operating system knows what application to use to launch that particular file because of the file extension. All of that way of folders and subfolders and file names, that's all managed by the operating system. Different operating systems manage those differently and use different extensions. Printers are hardware. Printers have to be managed by the operating system. And one of the things that printers involved with the operating system with printing files is the fact that printers are relatively slow, right? Because your CPU does things at billions of cycles per second. And it can read and write memory. Huge gigabyte files can be processed by RAM. Physical memory is a little bit slower. The hard drive's slower than the RAM memory. Well, the printer's slower than that. Right? And just consider this. If I have a 200-page document, I can load it in a few seconds. It takes me a lot longer than that to print the same file. So when I want to print a file, it's something that the CPU and the memory and even the hard drive can do very, very quickly, but the printer is going to take seconds or minutes or longer to print out those 200-page files. So it's a tedious process to have to go through and send that data out there. The operating system manages that. It does something called a buffer, where it sets aside some memory for the file that's going to be printed. It sticks it in this buffer, right? And then the buffer feeds to the printer the data as it needs to. So a term has been used for this called spooling. It's like taking thread and winding it up on a spool and then pulling it off of the spool as necessary when the printer can print it. So think of the buffer as the spool, and when you print a file, you don't actually send all that data to the file. You send all that data to the spool or the buffer, and it sits there and unspools at whatever rate the printer can handle it. And when the printer runs out of memory, runs out of paper, the spooling stops. You get an error message on the printer. You put new paper in. You say OK, and then the spooling continues. So it's kind of neat if you think about it, perhaps. Anyways, the point is you don't have to think about it because the operating system thinks about it for you. So what are some differences on operating systems? Early operating systems were command-line operating systems. You had to know specific commands to type in text. Right? The early operating systems in the 1960s, Unix in the 1960s, the DOS operating systems that were used for the IBM personal computer in 1981. These were all command line. Graphical user interfaces were introduced to the world in 1984 with the Macintosh, but Apple did not invent the graphical user interface. They were actually invented and prototyped and working correctly with Xerox PARC research group in the 1970s. And Steve Jobs went to Xerox PARC in 1979, saw a functioning version of the graphical user interface and got very excited about it and redoubled his efforts to get that type of an operating system to work at Apple. And with a product they actually had in 1983 called the Lisa, which was very expensive, $10,000, too expensive for a personal computer. And then the year later, 1984, the Macintosh, they had a graphical user interface, introduced that to the world, but it didn't really take off until Windows had a graphical user interface with Microsoft. So Bill Gates deserves, Steve Jobs deserves a lot of credit for getting it to the market, but not for creating from scratch the idea of the graphical user interface. Today, that's what we use for all our machines. Our tablets use it. We use our fingers instead of mice, instead of a mouse. We tap on the icons. We, double spread the squeeze and expand the icons. We flip with our fingers to move through the pages. And it's just us communicating in an intuitive way what it is we want the computer to do and how we want it to respond. In the future, very possibly you'll just talk to it, almost Star Trek-like. You'll just kind of speak to the computer and it'll know what you're doing, or sense your hand gestures as well and know what's going on without physically touching it from a distance, be able to sense your hand gestures. There are also operating systems for, in addition to personal computers and mobile devices like smartphones and tablets, there are also operating systems for even smaller or more special purpose called embedded operating systems. Your microwave has an operating system. It's embedded in its special purpose. You can't play solitaire, you can't surf the web, you can't write a research paper, you can't edit a photo with the operating system inside your microwave. But it has software that operates the hardware of the microwave. Your automobile anti-lock braking system has an operating system that manages the anti-lock braking. It senses the pressure you're placing on the brake, and it sends the signal to the brake pads to, make the brake stop. The anti-lock braking means that if it senses that the wheels have locked and it's starting to hydroplane, it'll unlock the brakes automatically and let the wheels start spinning. All that's happening for you automatically. You don't have to worry about it because the software is managing the hardware of the braking system in your automobile. And these embedded special purpose operating systems, that's what they are. They're special purpose. You can't use them to surf the web or edit a photo or, play solitaire. And bigger, as we go bigger, right? Network machines and supercomputers, they have their own operating systems as well. Because without software, hardware is useless. Hardware must have software to tell it what to do. Quick quiz number 1. Which of the following processing techniques allows a CPU to do more than one thing? For example, to have 72 tasks showing up on your task manager on only one computer that has maybe 1, 2, 4, or 8 CPUs. The answer is multitasking, which is letter C. True or false? Most operating systems today use a command line interface. That was true in the 80s. Even when Macintosh came out in 1984, most machines in the 1980s were the IBM personal computers using Windows DOS operating system. But this isn't 1980s, right? This is in the 2000 teens, and graphical user interfaces, GUIs, GUIs are the most popular. 10 years from now, we'll probably have something that's even better than graphical user interfaces. Blank is a task included with operating systems that allows you to keep track of the files stored on your PC. So file management is one of the things the operating system does. Memory management, CPU management, and others. Okay, DOS stands for Disk Operating System. It was a command line operating system. It's what came with the IBM personal computer in 1981 that Microsoft licensed to IBM, but they retained the rights to sell the operating system to clone companies that were making clone computers, and they became the operating system de facto standard for personal computers in the 1980s. Macintosh was its own separate thing where they controlled their own hardware and their own software. They never had a big market share, but they had good profits, Apple did, because they controlled the hardware and software themselves. This operating system in the 1980s from a DOS, it was command line. You had to know exactly what to type. It wasn't super intuitive to people. It was a lot more time to learn and work with. You didn't see 4-year-olds working on a computer in the 1980s. You do see 4-year-olds working on graphical user interfaces, because graphical user interfaces, like we see on Windows 10, are intuitive, like we see on almost every operating system today. And the idea behind Windows 10 is Microsoft was trying to use the same operating system on their desktops and their laptops and on larger screen devices. So if you get a 40-inch screen or a 100-inch screen, Windows has an operating system, Windows 10, that they want you to use on that device as well. Macintosh makes their own hardware and software, which is something IBM should have done but didn't do. They didn't write their own software. They let Microsoft have that. And that gives them the ability to be more control in exactly what the product is they're going to be releasing to the market. It gives them the ability to be a closed environment and probably charge a higher price. They don't have the same market share, but they make more money per sale because of that. So the Mac OS for desktops and laptops is different than the iOS, which we're going to talk about a little bit later, which is Microsoft operating system for mobile devices. So the OS was... they've had that proprietary operating system going all the way back to the Macintosh in 1984. The current version of their operating system is called OS X, and they keep that same OS X base, and as they come up with new versions of the operating system, they give them new names. So OS X Mountain Lion, OS X Mavericks, OS X Yosemite, OS X El Capitan. These all... and we even dropped the OS X. We'll probably just talk about Yosemite or Mavericks or El Capitan. And then there's a server version of this as well. If you want to, it's an operating system that will manage your resources, your files, your printers, your web pages, whatever it is that you're serving up to the clients that are requesting it from the server. And there's a screenshot of OS X as the Mavericks screenshot, but it's GUI based and looks pretty similar. Now Unix is an operating system that's been around for a while. It was command line, worked on mid-range, larger, expensive computers in the 1960s. There were no personal computers in the 1960s. It wasn't until the 70s that personal computers came about, and even then they were pretty expensive, or they were lower-end hobbyist machines until the late 70s. So Unix is an operating system that's been around for a while, and it still exists today. There are people who use Unix today, especially computer scientists and computer engineers, really technical people. It's command line based, although it has a graphical user interface front end to it. A lot of the people who use this are so familiar with the technology, they do it command line based. The reason we mention Unix from a historical perspective is because it was what Linus Torvalds replicated when he wrote Linux, a small version of Unix. He wrote and he shared his working operating system with the world That working operating system is called Linux, and it is open source, and it's available, and people use it today. Originally, Linux was command line, but there are now open source graphical user interface versions of Linux. I think this next slide shows a Linux operating system from a graphical base, so that looks very much like a Mac. And the idea behind Linux is that it is open source, and lots of people are working on it and putting the features they like from the Mac OS X or from Windows 8 or Windows 10, and they're making sure that Linux has those features of multitasking and the ability to handle different print drivers and device drivers, so you can plug in different cameras and scanners and everything you want into it. And because it's free, people like it, and it works well. Chrome OS, this is an idea that they're using, where Google's using this, where we've got a laptop, and the premise is, the idea behind this is, most of what I'm doing on this laptop is accessing data and programs that are available on the cloud. So as long as I've got a CPU and a little bit of memory and a network connection, then really what I want to do is I want to manipulate cloud stuff. And a Chrome device doesn't really have a classic operating system. It's easier on the CPU management, it's easier on the memory management, because everything you're needing is cloud-based and network-based rather than being standalone. Now, you can take a Chrome system and you can have the network be off of the network and still do some processing, but you're really limiting your functionality there. So that hasn't taken off in a huge way, but it's a neat idea as allowing you to take a lower cost device, because you're not having all the hardware and storage you need physically here. You're going to take advantage of particularly storage of your applications and storage of your data in the cloud, and just process it on the client side, sometimes called a thin client, THIN, because you're not having to invest as much in the hardware there. And you want a low-cost operating system if you're going to go that thin client route. Which of the following is the most recent personal version of Windows? Windows 10 is the latest version. True or false? Linux is an open source operating system available free on the internet. That is true. Operating systems most commonly used on the Apple personal computer is OS X. El Capitan is the latest version of OS X. And then just to wrap up here, let's talk about mobile phones and tablets and these mobile devices. Android was acquired by Google in 2005. It grew out of a Linux approach, which again, remember, Linux is open source. People can work on that code. So it was used a Linux kernel to migrate it to mobile and phone devices. Google bought it in 2005 and remains involved heavily in the development of Android. Jelly Bean, Kit Kat, and Lollipop are the versions of Android operating system. This follows an ABCD lettering scheme. So the last three were J, Jelly Bean, K, Kit Kat, and L, Lollipop. M, N, O will be coming next, and they'll come up with creative names for that. Mac OS X doesn't use that. I don't know where they come up with their names, but I kind of like the Android approach of using letters to begin the words here, so you kind of have an idea where they came through the list. So this is a really popular operating system for phones, and the other really popular operating system for smartphones is the Macintosh's iOS, which is their phone and tablet operating system. And we see a screenshot there from our book about those two. I mention these two because they're by far the two most common operating systems. Worldwide, Android's bigger than iOS. And this chart, this is from 2000 up to 2014 by IDC. And you can find different charts out there if you just do a Google search and compare them. It depends on the criteria you're talking about. Are you talking about the number of jobs involved? Are you talking about the amount of revenue generated? Are you talking about within the United States or worldwide? Within the United States, this would be a very different chart because iOS is more common in the United States than Android is. But worldwide, Android is more common than iOS. And if you thought about it for a while, realizing that Android is based on a free operating system and is certainly lower cost or freely available, whereas the iOS is in a closed system for the Apple and a more expensive hardware-software combination. To get that package, you can realize that it's a lower cost option, and that's going to certainly help particularly in countries where they don't have the disposable income that people have in America. And I know you feel like, oh, I don't have any disposable income. Believe me, as an American, you have more disposable income than most people throughout the world. Utility programs, as we really start to wrap this up, the idea behind utility programs is still considered system software, but it's not the operating system, right? The operating system has the core essential things that are necessary. In fact, I don't have it on this slide, but the core of the operating system is something called the kernel, and the kernel is what gets loaded when you boot up the operating system. So booting up the operating system is bringing the kernel in, and that's got the bare bone basic requirement stuff, right? CPU management, memory management, file management, input output management, keyboard monitor, so that you can just do the basic things. And the operating system does all those other things that we've already talked about. But there's other things that help the system operate, but they aren't core to the operating system. Doing backups, doing antivirus, right? So in fact, if we look at some suites out here, let me go down one page, I'm going to do this out of order. If you go to Wikipedia and look up utility software, you will see that these are, I think, the list, or at least part of the list of what shows up there. Antivirus, archiving backup programs, data compression, debugging, disk cleaning, disk defragmenting. The idea behind disk defragmenting is that our files, over time, you add files and delete files and modify files and add pages to Word documents and delete slides from a photo, from a presentation. And those files end up being saved on that hard drive, but they get saved on various sectors and tracks in different places and gets kind of scattered, and defragmentation is going through there and cleaning it up. File management and hex editors and blah, blah, blah. None of these things are in the kernel of the operating system, the core basics, and these things are arguably part of the operating system or not. Microsoft probably has support for a lot of these built into Windows 10. Macintosh, Apple has a lot of support to these built into the OS X operating system. The iOS might, on mobile devices, not as much, but some of these things might be there. So the operating system can support these utilities, but I'm going to go back to where I was. Third parties, right? Utilities, that last bullet there, utilities are also available from third-party developers as standalone products and suites. And one of the nice things about this is Norton can't compete with Apple or Microsoft when it comes to creating an operating system. But there's a space for them to have a business and to provide a value-added product by providing a utility that users want to help make their time working with their computer hardware better. And there are other suites out there. If you do a search, you'll find that, top 5 system utility suites. And the idea on a suite is that it's more than one program, right? It's not just one utility, but it's a collection of related utilities. So a suite means 2 or more pieces of software that correspond together. A suite in this context means 2 or more programs. So WinZip, the people that make the compression program, you can even see there maybe on the icon, fix PC program problems, restore speed, protect privacy, improve startup time. That's from the screenshot. And there are others. So there are companies out there that aren't Microsoft and Apple, but they're still able to create not application programs, but programs that help the computer operate a little more effectively. Right? They're writing utility programs. So disk diagnostics would be an example, making sure that, what happens if the program that goes out and says, is there a bad sector? Is my hard drive about to fail? Right? That's a utility. It's not required, but it's nice to have. Uninstall utilities. When you want to take a program off your machine, you don't just go to the folder that contains where the program is installed and delete it. You actually want to run an uninstall program, because it goes through and not only deletes those files, but installing a program puts programs in different folders and has different temporary files where it holds the files that it's using, and library files and everything else. So an uninstall program is a more effective way to remove a program than simply deleting the executable or deleting the folder where it's in. Microsoft's operating system has an uninstall utility, and there are also third-party uninstall programs that you can get. cleanup. This is going through and deleting the temporary files. It's not removing any installed program, but it's just saying some of the temp files from web browsing or some of the temp files from downloads and cleaning those up. And again, Microsoft can probably help that with you, and there's third parties that can help that. File compression programs. We think about WinZip and zip programs that allow you to take 2, 3, 4 programs and compress them down into a single .zip archive that's smaller in size and also easier to then send in an email or upload to the cloud or save onto a storage device, DVD or thumb drive for later use. Those are out there. Windows has that built into Windows 10, but there's also third-party programs that you can use. 7-Zip is the one that I like to use, but there are others out there. Backup and recovery. You should be backing up your data. You should be backing up your data. You should be backing up your data. What data do you have right now that if you lost it today, you would be very sad you don't have it backed up? Absolutely back that data up. Now, how do you back it up? Well, you can do a file save as and just take a file and make a copy of the file, right? Because remember, save as gives you a second file with either a different name and or a different location for saving that. Or you can use a utility to help you with your backups, and the utility will automatically do the backups for you every day or every week, and it'll help you recover when you need to recover. The utility have that built in. Windows has that built into the operating system, but there's also third-party backup programs that you can use, and so on. So that's the idea behind utilities. Antivirus, anti-spyware, firewalls, right? All these things, and we're going to talk about security later in Unit 3. But some of these are built into your operating system, but there are third parties out there that are making these products as well. So we're talking about utilities there. Last content slide, the future of operating systems. In the future, operating systems are going to become more user-friendly. GUI operating systems were not very friendly. Command line operating systems are not very friendly. Today's GUI operating systems are more friendly. In the future, voice-based and gesture-based, without having to physically touch the screen or touch a mouse, will be even more friendly. They'll be, as I say, use voice and gesture, more stable and self-healing. Operating systems in the past used to get what's called the blue screen of death. We don't get that very much anymore. Operating systems tend to be pretty productive. They tend to be anticipate and know what's going on and have robust code. Open source actually helps that. The fact that Linux is open source and lots of eyes are looking at the code, they're able to anticipate the kinds of problems and they write better code. Some people would argue that Linux is better written code than either the Mac OS or the Windows operating system. And Windows and Mac people have learned from looking at Linux, and they've incorporated some of that into their own operating system. So we've seen a significant improvement in the reliability of operating systems. Continue to include security and technical improvements, right? Get better, better, better. Synchronizing, coordinating data among your various computing devices. You're going to have 2, 3, 4, 5 different computing devices. Data is going to be stored in the cloud. You're going to be able to have access to all that data from all your devices at any device at any time. It's going to be much more seamless. And, right, so it's just going to be a good thing. And in class, we talked about some things that the book doesn't talk about as well, which hopefully you got to enjoy that discussion. Okay. Our last quick quiz. Which of the following is the type of utility program used to make a file smaller for transferring over the internet? That would be a compression, file compression. C. Thing about not only file compression, but to archive it, zip archive it, you can put multiple files into a single compression. So it compresses it and combines. But C is correct there. True or false? File management program can be used to see the files located on a storage medium. That's true, right? File management, memory management, CPU management, those are all things that our operating system does for us. Number 3, a blank is a duplicate copy of one or more files that can be used if there is a problem with the original file. So that's a backup. You can write your own backup doing file save as, or you can use a backup utility to be even more efficient with that. Okay, so what we looked at was system software versus application software. Chapter 5, system software. Chapter 6, application software next week. Functions of the operating system, all the hardware that's being managed, booting the computer, providing user interface. Personal computer operating systems. Windows has one, Windows 10. Microsoft has one, Windows 10. Apple has one, OS X. And Linux. Those are probably the 3 most common for that market. What about for mobile phones? The 2 most common are Android, which is open source from Google, and biggest worldwide, and iOS from Apple, which is the biggest in the United States. Utility programs and the future of operating systems. Thank you. Have a good day.